I'm just going to go back to here. So I was turning the root into a factor. So x equals a half. And then I was saying we need to get rid of the divided by 2. So we do that with a multiplied by 2 and then multiply by 2 to balance it out. I'm going to write the tidied up version. And then we need to, oh, sorry, not that. I need to move this. So it's a plus 1. So I minus 1 and then a minus 1 over here. So 2x minus 1 is the factor. And then I'm going to just divide that in. So 2x minus 1 divided into 4x cubed minus 8x squared. K was minus 1, so that becomes minus 1x, and then plus 2. Alrighty, and then just divide in. So 2x into 4x cubed is 2x squared, and then 2x squared multiplied back out is 4x cubed minus 2x squared, minus this and plus this. So I get minus 6x squared minus 1x. Sorry, I brought down the minus 1x. So then we go again. 2x into minus 6x squared is minus 3x. And then multiply this out in the same way. So minus 3x by 2x is minus 6x squared. Minus 3x by minus 1 is plus 3x. Change the sign, so minus becomes a plus and plus becomes a minus, and they cancel. Then I have minus 1x minus 3x is minus 4x, and then bring down the plus 2, and then go again. So 2x into minus 4x is minus 2. Multiply that by what's over here. So that is minus 4x plus 2. Change the sign, so minus becomes a plus, plus becomes a minus, and they cancel. So it works. So then I take that, which is 2x squared minus 3x minus 2. And I'm going to, I suppose, minus b. You always do minus b. So minus b plus or minus the square root of b squared minus 4ac over 2a. A is 2, b is minus 3, c is minus 2. Okay, so we get minus 3 plus or minus the square root of minus 3 squared minus 4 times 2 times minus 2 over 2 times 2. So that's 3 plus the square root of minus 3 squared minus 4 times 2 times minus 2 over 2 times 2. So I'm getting 2 on the plus side, and then on the minus side, delete minus, I'm getting minus a half. So the roots are x equal to 2, x equal to minus a half, and then from the beginning, where is it? X equals a half. So there are your 3 roots. All right, that's that one. Not sure how you're supposed to fit it in the little box, but that's it. Okay, the second one here, log to the base 9 of xy in terms of log 3 to the x and log 3 to the y. Okay, so the first thing we need to notice here is that the base here is 9, but the base that we're looking for is 3. So we have to do a change of base. So log to the base 9 of xy will become, so it's log to the base 3 over log to the base 3 because I want to change my 9 into 3's. And then the top bit goes there. And the bottom bit goes there. Sorry, I don't know why I wrote 9. I literally said the top bit goes there. So the top bit, which is xy, goes there, and the bottom bit then okay. Now, right, sorry. So I wanted to change a 9 into a 3, so I changed it to a 3, and then the xy goes on the top line and the 9 goes on the bottom line. So an xy like this, so this here is a product, and a product turns into an addition. So that's log to the base 3 of x plus log to the base 3 of y. And then the bottom line, because there's no x's in it, you can type it into your calculator, and it's 2. Okay, this one here. So this is obviously the thing I just did. So that is log to the base 3 of x plus log to the base 3 of y over 2. So they're the same, because that's what I did in the last question. And that equals 5 over 2. So if I multiply by 2, I'll get rid of these. Yeah? Okay, so I have log to the base 3 of x plus log to the base 3 of y equals 5. And then I have log to the base 3 of x times log to the base 3 of y equals minus 6. Okay, so I can't work with all these logs. They'll just stress me out. So I'm going to change it. I'm going to change log to the base 3 of x into a. And I'm going to change log to the base 3 of y into b. Yeah, so now it becomes a plus b equals 5. And the second one is a, b equals minus 6. So it is a simultaneous, but it's a weird one. It's a, what is it called? Substitution. So I'm going to rearrange this. So a equals minus 6 over b. Yeah, so all I did there was I divided by b to isolate the a. Yeah, and then I'm going to take this and sub it in for a in the other equation. So I get minus 6 over b plus b equals 5. I'm going to make these fractions and I'm going to multiply across by the b. They cancel. So minus 6 plus b squared equals 5b. And then I'm going to bring this across. So minus 5b to cancel and minus 5b. Because it's quadratic, I'm going to need to do minus 5b minus 6 equals 0. You need equals 0 when it's quadratic. Yeah. So you can do a minus b formula on that again. So a is 1, b is minus 5, and c is minus 6. So minus b plus or minus the square root of b squared minus 4ac over 2a. There goes my calculator. Okay. So minus 5 plus the square root bracket minus 5 squared minus 4 bracket 1 bracket minus 6 over 2 bracket 1 So that on the plus side is 6. And then b on the minus side, minus equals -1. Yeah? So then we have that a is, I'll do the logs in a second, but we have a is -6 over b. Okay, so when b is 6, a is -6 over 6, so a is -1. Yeah? And when b is -1, a is -6 over -1, so a is 6. They're literally opposites. All right, so I'm going to go back up here to the red. So I said log to the base 3 of x equals a, and I've got 2 values for a over here. So log to the base 3 of x. Okay, so but log to the base 3 of x equals a. Therefore, log to the base 3 of x equals -1. And then switch to indices. So the base of the log becomes the base of the indice. The answer becomes the power. And the argument, isn't that what it was called? The argument becomes the answer. So x to the power of -1 is 1/3. So that's that one. This one here. So a is 6. But log to the base 3 of x equals 6. Sorry. Log to the base 3 of x equals a. So therefore, log to the base 3 of x equals 6. And then do the same thing. So the base is 3, the power is 6, and the argument becomes the answer. So 3 to the power of 6, 729. So there is 1, 2 answers for x. Oh, sorry. I did the same thing again there. Base, base. The answer becomes the power, and the argument becomes the answer. Okay, and I don't think we're going to have to actually do a whole lot over here, but we have to get the values for y. So b is 6, but log to the base 3 of y equals b. So log to the base 3 of y equals 6. So it's going to be the same as the one I just did there. 3 to the 6 equals y, and that was 729. And then this one here, log to the base 3 of y equals -1. So 3 to the -1 equals y, so 1/3 equals y. Okay, so 2 values for x and 2 values for y. Express your answers in their simplest form. We did. Prove that if 3 parallel lines cut off equal segments on some transversal line, then they will cut equal segments off any other transversal line. It just has to be like very close to perfect. I'll go through the thing with you now in a sec. Where are the proofs here? So the first 5 marks were for your given and your to prove, and it needed to be like, you need both. If it's only a given or a to prove, you don't get full marks. Sorry, I'm going to put this down here a bit. So there's the given and the to prove for the, sorry, the given and the diagram is what I meant. Then down here, you have the construction. And obviously then the construction links with the construction in the diagram. So again, the construction plus the diagram was the next 5 marks. And then the rest of the marks, if I can zoom out enough. Oh, sorry. Now, the rest of the marks is for the proof. So like, there's no point in me talking through it. I talked through it in class when I taught it to you. You just need to know it. Like it needs to be very close to perfect. I'll show you the marking scheme. So here's the given 3 parallel lines P, Q and OR, transversal M intersecting P, Q and OR at A, B and C respectively, such that AB equals BC, stated or indicated. Transversal M, I mean, there just needs to be so much detail. That's your diagram and you're given. Your to prove, what are you trying to prove? And then your construction, so construct the line L with E, construct the line L through E parallel to M and let L intersect P at Q and OR intersect OR at Y. And then your proof, so going through and finding angle, side angle. So yeah, okay, that's your last. I don't know where the marks are for that. There, so 10 marks in total. Okay, so that's the proof. So I've clipped it in at the side there, but you just need to know it. Not really sure how it happened, but this question just got snipped off the paper. I don't know why, but I'm going to get you to do it maybe for homework because it's a nice question. So anyway, there was an extra question. Given a line segment of length 1 unit, show clearly how to construct a line segment of length √2 using only a compass and a straight edge. Hence indicate a line segment of length √2 minus 1 units. Okay, so this here, this line that's here is what they've given you, and we are to assume that that is 1 unit long. Yeah? So I'm going to do this, but it's obviously on the iPad, so it's not great. It's not great, but it's fine. Okay, so I'm going to open my compass. I'm sure I'm not going to be able to do this at all. Sorry, I can't, because I can't use the compass. I have it in here. So this line here is the line we've been given, right? So you need to use this as your radius and then draw your circle. You've got your 1 unit, and this is your hypotenuse. So over here, I do the hypotenuse. So the length of that is √2. Okay, now I might show you this in class just to kind of really get the point across. But you need to construct √2 like this on a number line. So you open your compass to go from here to here, right? So your compass is that width. And then you put it down here and you strike your arc. So now that line segment there, and the question asked you to like, I can't remember how it said it, but it said like indicate clearly. So I will take this off because I don't want it to be on this, but this line here is your line segment. Is that working? Sorry, I am writing on that. It just doesn't seem to be syncing. So that line there is your line segment √2. And then the other one we wanted was √2 minus 1. So maybe I can do it this way actually. Hang on. So that's √2. That's the line segment √2. Yeah? Then √2 minus 1 is √2 removing 1. So like take that bit away. So in the line segment √2 minus 1 is just that bit. So you just have to indicate that. You just have to say that if I change the colour, the yellow one